From the earliest moments of human consciousness, we have gazed up at the vast expanse of the sky, a realm of boundless freedom and captivating mystery. The desire to take flight, to soar among the birds and touch the clouds, is a yearning woven into the very fabric of our being. Across cultures and throughout history, this primal longing has manifested in myths, legends, and the persistent pursuit of making the impossible a reality. It is a testament to the enduring human spirit, our relentless curiosity, and the unyielding belief in pushing beyond the limits of what we perceive as possible. The allure of flight is more than just a physical desire. It represents a deep-seated yearning for transcendence, for breaking free from the constraints of gravity that bind us to the earth. It speaks to our innate desire to explore the unknown, to conquer new frontiers, and to experience the world from a perspective that was once relegated to the realm of dreams. The history of aviation is a testament to this enduring human spirit, a chronicle of ingenuity, determination, and the unwavering belief in the power of innovation. For centuries, the dream of flight remained just that, a dream, a tantalizing possibility that seemed forever out of reach. Yet the human spirit, with its insatiable thirst for knowledge and relentless pursuit of progress, refused to let go of this aspiration. Early inventors, visionaries who dared to challenge the accepted limits of their time, took those first tentative steps, experimenting with kites, gliders, and other contraptions, seeking to unlock the secrets of the skies. While many of these early attempts met with failure, each endeavor, each setback, brought us one step closer to understanding the principles of flight. Myths and legends reflect our deepest desires and fears. The dream of flight features prominently in ancient folklore. From Icarus to Kung Fu Pan, myths highlight our fascination with flight. These tales inspired generations of dreamers and inventors. Imagining flight planted the seeds for its realization. Early civilizations made tangible attempts to conquer the skies. The Chinese invented the kite, providing insights into aerodynamics. Leonardo da Vinci's designs demonstrated a keen understanding of flight. His work laid the groundwork for future inventors. Da Vinci's observations of birds inspired future generations. The dawn of the 20th century marked a pivotal turning point in the history of aviation. A moment when centuries of dreams, experiments, and aspirations coalesced into a tangible reality. In 1903, on a windswept beach in Kitty Hawk, North Carolina, two brothers, Wilbur and Orville Wright, achieved what had long been deemed impossible: sustained, controlled, powered flight. Their creation, the Wright Flyer, a fragile biplane constructed from wood, fabric, and wire, took to the skies for a mere 12 seconds, covering a distance of just 120 feet. Yet in those fleeting moments, they ushered in a new era. The Wright brothers' achievement was not merely a technological triumph, it represented a profound shift in human consciousness. The seemingly insurmountable barrier between earth and sky had been breached, forever altering our perception of what was possible. Their success ignited a global fascination with aviation, inspiring countless others to take to the skies and pushing the boundaries of this newfound technology at an unprecedented pace. The impact of the Wright brothers' achievement extended far beyond the realm of aviation. Their pioneering spirit, their relentless pursuit of innovation, and their unwavering belief in the power of human ingenuity served as an inspiration for generations to come. Their legacy continues to shape our world today, not just in the skies, but in every field that embraces the spirit of exploration, innovation, and the relentless pursuit of progress. The history of aviation is not a linear progression from those first tentative flights to the sophisticated aircraft that grace our skies today. It is a tale of daring leaps forward, punctuated by setbacks, rivalries, and moments of sheer brilliance. It is a story of individuals who dared to dream, to challenge the status quo, and to risk everything in pursuit of their vision. From the early pioneers who braved the skies in fragile, often unreliable machines, To the test pilots who push the limits of speed and altitude, to the engineers and designers who constantly sought to improve upon the existing technology, the journey of aviation is a testament to the indomitable human spirit. In the following chapters, we'll embark on a captivating journey through the history of aviation, tracing its evolution from those early myths and legends to the modern marvels that connect our world today. We will explore the key technological advancements, the visionary individuals who shaped the course of aviation history, and the profound impact this revolutionary technology has had on our world, from warfare to transportation to our very understanding of our place in the cosmos. Fasten your seatbelts and prepare to be transported as we delve into the incredible journey of aviation, a testament to human ingenuity, courage, and the eternal quest to conquer the skies. The human fascination with flight is a primal yearning woven into our existence. Since time immemorial, we have gazed up at the sky, ignited by birds soaring above. This longing to break free from Earth and touch the heavens is a constant in human history. It reflects our curiosity, thirst for exploration, and belief in achieving the impossible. Across cultures, the dream of flight appears in myths, legends, and art. From the Greeks, we have Icarus, whose wings melted when he flew too close to the sun. This myth highlights the allure and risks of flight. The Egyptians envisioned gods traversing the heavens in winged boats. These beings symbolized power, freedom, and transcendence. Egyptians also experimented with kites, hinting at early aerodynamics. From Tibet to the Pacific Islands, from the Amazon to Africa, the dream of flight is universal. These stories inspire us to look to the skies and imagine the impossible. In ancient China, the dream of flight took on an enchanting form. Legends tell of skilled artisans crafting intricate flying machines and harnessing the wind. Lu Ban, a master craftsman, is credited with inventing a flying wooden bird. These tales underscore the enduring human fascination with flight. The Chinese pioneered kites, which evolved into objects of practical and symbolic significance. Kites were used for fishing, military signaling, and scientific experiments. Kites provided insights into aerodynamics, paving the way for human flight. Other cultures also experimented with kites, contributing to flight knowledge. In ancient Greece, Archytas designed a steam-powered pigeon. These early attempts represent crucial steps towards conquering the skies. They demonstrate human curiosity, the willingness to experiment, and the belief in realizing audacious dreams. As civilizations advanced, the dream of flight transitioned from myth to scientific inquiry and engineering. Inventors applied mathematics, physics, and observation to unlock the secrets of lift, drag, and propulsion. Abbas ibn Firnas, a 9th century polymath, designed a glider-like contraption for controlled flight. His device, made of wood and fabric, allowed him to glide a short distance. Leonardo da Vinci meticulously documented bird flight mechanics, laying groundwork for future aviation. From Arabia to Renaissance Italy, the pursuit of flight captivated dreamers and inventors. Each attempt brought humanity closer to realizing the dream of soaring among the clouds. The Renaissance, with its emphasis on humanism, scientific inquiry, and artistic expression, breathed new life into the ancient dream of flight. Leonardo da Vinci, the embodiment of the Renaissance ideal, stands as a towering figure in the history of aviation. His insatiable curiosity and meticulous documentation provide a fascinating glimpse into the mind of a genius grappling with the complexities of flight. Da Vinci's legacy extends far beyond his artistic masterpieces. He stands as a testament to the power of human curiosity and the enduring allure of conquering the skies. The 19th century witnessed an explosion of scientific and technological advancements, setting the stage for powered flight. The Industrial Revolution provided fertile ground for the development of technologies and materials that would make flight possible. The steam engine offered a glimpse into mechanical propulsion, while advances in metallurgy provided the strength and lightness required for constructing airborne vehicles. Inventors and tinkerers across the globe embarked on intense experimentation. Gliders became a focal point for innovation. Pioneers like Sir George Cayley, Otto Lilienthal, and Octave Chanute made significant strides in understanding the principles of flight. These early aviators faced technical challenges and widespread skepticism. The dream of flight was considered fantasy by many. Yet, these pioneers persisted, driven by an unwavering belief in their vision. Sir George Cayley, an English baronet, is widely regarded as the father of aeronautics. Cayley identified the four forces of flight: lift, weight, thrust and drag, and articulated the concept of a fixed-wing aircraft. He built and tested numerous gliders, including some large enough to carry a human. His triplane glider in 1853 is considered the first true heavier-than-air craft to achieve stable, controlled flight. Cayley's work laid the foundation for rapid progress in aviation. Otto Lilienthal in Germany conducted groundbreaking experiments with gliders. Lilienthal believed in replicating the principles of natural aerodynamics. He made over 2,000 successful flights with his gliders. Lilienthal's gliders were controlled by shifting the pilot's weight. His work earned him international recognition and inspired others. Lilienthal believed flight could transform human society. Tragically, he died in 1896 in a glider crash. His legacy inspired future generations of aviators. Lilienthal's work pushed the boundaries of what was possible. Octave Chanute, a French-born civil engineer in the United States, emerged as a leading figure in aviation. Chanute was a meticulous observer and advocate for aviation development. He corresponded with aviation pioneers worldwide, collecting and disseminating their findings. Chanute conducted extensive experiments with gliders, refining their design. He recognized the importance of stability and control in flight. His gliders used lightweight materials and innovative structural techniques. In 1896, Chanute's team conducted successful glider flights near Chicago. These flights captivated the public's imagination and legitimized the pursuit of flight. Chanute served as a mentor and inspiration to many, including the Wright brothers. His contributions extended far beyond his own experiments. Wilbur and Orville Wright, bicycle mechanics from Dayton, Ohio, approached flight with mechanical aptitude and meticulous attention to detail. Inspired by Lilienthal and Chanute, they studied aerodynamics and experimented with wing designs. The Wright brothers developed a revolutionary system of wing warping for control. They designed and built their own lightweight engine and propellers. On December 17, 1903, Orville Wright piloted the Wright Flyer at Kitty Hawk, achieving the first controlled, sustained flight of a powered aircraft. The flight lasted 12 seconds and covered 120 feet, marking a pivotal moment in history. The Wright brothers' achievement inspired a wave of innovation and experimentation. Their work marked the beginning of a revolution in aviation. Inventors and entrepreneurs worldwide built upon their success. The age of experimentation gave way to the age of flight. Humanity began to explore the boundless possibilities of this revolutionary technology. The Wright brothers' legacy forever changed our relationship with the sky. World War I marked a turning point in aviation, transforming flying machines into instruments of reconnaissance, bombing, and combat. Aircraft were initially used for observation, gathering intelligence on enemy movements. The information relayed back proved invaluable to commanders. The skies held potential for more than just observation. Bombing raids targeted enemy supply depots and industrial facilities. The psychological impact of air raids foreshadowed the role of strategic bombing in future conflicts. The roar of engines became a haunting symphony of destruction. The war redefined the nature of warfare and aviation. Aircraft evolved rapidly, becoming faster and more maneuverable. The dawn of aerial warfare transformed the battlefield. Aviation became a crucial element in military strategy. The skies above the Western Front transformed into a deadly arena. Aircraft evolved into faster, more maneuverable machines armed with machine guns and bombs. Fighter pilots emerged as a new breed of warrior. They engaged in deadly aerial combat, their courage and skill tested. Early dogfights were chaotic and terrifying encounters. The invention of the interrupter gear revolutionized aerial warfare. Fighter aircraft became lethal weapons of war. Aces like the Red Baron and Eddie Rickenbacker became legendary. Countless pilots met their end in the skies. Aerial combat was a brutal reality of war. World War I transformed aviation at a breakneck speed. Aircraft evolved rapidly, becoming stronger and more agile. New materials and engine technology advanced aircraft performance. Streamlined designs and aerodynamic refinements enhanced capabilities. Technological advancements had a profound impact on aviation. Lessons learned during the war paved the way for progress in commercial aviation. Pilots emerged as pioneers, pushing the boundaries of flight. World War I served as a crucible for aviation. A new era of flight was forged. Humanity's relationship with the sky was forever altered. World War II saw aviation play a pivotal role on a global scale. Sleek, all-metal monoplanes dominated the skies. Aircraft evolved into strategic weapons shaping entire campaigns. The Luftwaffe played a key role in the Blitzkrieg. The Battle of Britain pitted the Luftwaffe against the Royal Air Force. Technological advancements were breathtaking. Radar transformed aerial warfare. The jet engine ushered in a new era of high-speed flight. Jet-powered fighters made their combat debut. The skies were a crucible of innovation. Lessons learned shaped the course of aviation for decades. The foundation for the jet age and space race was laid. As the dust settled on the battlefields of World War II, a world weary from conflict turned its attention towards rebuilding and recovery. Amidst the rubble and the ruins, a new era was dawning, an era defined by technological innovation, economic prosperity, and a collective desire to break free from the constraints of the past. Aviation, forever altered by the crucible of war, emerged as a powerful symbol of progress and interconnectedness, its potential for transforming transportation, shrinking distances, and connecting people across continents now undeniable. The war had left an indelible mark on the aviation industry, leaving behind a surplus of aircraft, trained pilots, and a wealth of technological advancements just waiting to be adapted for civilian use. Military airfields, once bustling hubs of combat operations, were transformed into civilian airports. Their runways extended, and their terminals expanded to accommodate the anticipated surge in air travel. Aircraft manufacturers, their factories retooled for peacetime production, turned their attention towards designing and building aircraft tailored for the burgeoning commercial market. The immediate post-war years were a time of improvisation and adaptation, as airlines scrambled to meet the growing demand for air travel. Surplus military transport aircraft, stripped of their guns and bomb bays, and outfitted with rows of seats, became the workhorses of the fledgling airline industry, ferrying passengers and cargo across countries and continents. These early passenger aircraft, while lacking the comfort and amenities of their modern counterparts, offered a tantalizing glimpse into the future of air travel, a future where speed, convenience, and affordability would make flying accessible to the masses. On July 27, 1949, a sleek silver aircraft with swept wings took to the skies over Seattle, marking a watershed moment in aviation history. The Boeing 377 Stratocruiser symbolized post-war optimism and the transformative power of technology. With its pressurized cabin and spacious interior, the Stratocruiser epitomized the glamour of early jet-age air travel. The jet age represented a fundamental shift in how people perceive time and distance. Jet travel shrank the world, bringing distant cultures within reach and fostering global interconnectedness. Air travel became increasingly accessible to the middle class, opening up new possibilities. The introduction of jet aircraft revolutionized air travel, ushering in an era of speed, comfort, and efficiency. The de Havilland Comet Boeing 707 and Douglas DC-8 were pioneers of commercial jet service. Early jetliners, with their sleek wings and powerful engines, significantly reduced travel times and opened new routes. The jet age not only transformed the experience of air travel, but also had a profound impact on the aviation industry itself. Airlines, once small, often family-owned businesses, grew rapidly, expanding their fleets, adding new routes, and investing heavily in infrastructure to keep up with the burgeoning demand for air travel. The competition among airlines intensified, leading to innovations in aircraft design, improvements in customer service, and perhaps most importantly, a steady decline in airfares, making air travel accessible to a wider segment of the population. The development of larger, more fuel-efficient jetliners, such as the Boeing 747, nicknamed the Jumbo Jet, which entered service in 1970, further democratized air travel, making it possible to transport hundreds of passengers across vast distances at a fraction of the cost of earlier aircraft. The 747, with its distinctive humpbacked design and its ability to carry over 400 passengers, became an icon of the jet age, a symbol of human ingenuity and the shrinking world. Air travel was no longer the exclusive domain of the elite. It was becoming a viable option for families, students, and budget-conscious travelers. The growth of the aviation industry also had a ripple effect on other sectors of the economy, creating jobs in manufacturing, tourism, hospitality, and related industries. Airports became bustling hubs of activity, not just for travelers, but also for businesses involved in cargo transportation, logistics, and international trade. The world was becoming increasingly interconnected, and aviation was at the forefront of this transformation, facilitating the flow of people, goods, and ideas across continents. Even as jet aircraft were transforming the landscape of commercial aviation, a new frontier beckoned supersonic flight. The sound barrier, once considered an insurmountable obstacle, had been broken in 1947 by Chuck Yeager in the experimental Bell X-1 rocket plane, and the race was on to develop aircraft capable of sustained supersonic flight. The allure of traveling faster than the speed of sound, of shrinking travel times even further, captured the imaginations of engineers, politicians, and the public alike. The Concorde, a joint British-French project, emerged as the most ambitious and ultimately successful supersonic transport program of its time. This sleek, delta-winged aircraft, with its distinctive droop nose and powerful engines, was a marvel of engineering, capable of cruising at twice the speed of sound, or Mach 2, at an altitude of 60,000 feet. On January 21, 1976, the Concorde made its commercial debut, with simultaneous flights from London to Bahrain and from Paris to Rio de Janeiro, marking a new chapter in the history of aviation. The Concorde, with its luxurious accommodations and its ability to cross the Atlantic in under 4 hours, became a symbol of technological achievement and national pride for both Britain and France. It attracted a devoted following among celebrities business executives, and those seeking the ultimate in high-speed travel. However, the Concorde's high operating costs, limited range, and concerns about noise pollution, particularly the sonic boom it generated when it broke the sound barrier, ultimately limited its commercial viability. While the Concorde may have been a technological marvel, it was the subsonic jet airliner that truly revolutionized air travel, making it accessible to the masses and transforming the way people experience the world. The jet age ushered in a new era of mass tourism, as airlines offered affordable package holidays to destinations near and far. Families could now afford to spend their vacations on sunny beaches thousands of miles from home, while students could embark on backpacking adventures across continents, experiencing different cultures and expanding their horizons. The growth of air travel also had a profound impact on business, facilitating international trade, investment, and collaboration. Business executives could now attend meetings, negotiate deals, and oversee operations in multiple countries within the span of a few days, shrinking the world and fostering globalization. The ease of air travel also made it easier for families to relocate for work or for personal reasons, contributing to the growth of multinational corporations and the emergence of a more interconnected global workforce. The jet age also had a profound cultural impact, shaping fashion, music, art, and literature. The glamour of air travel, the excitement of flying, and the allure of distant destinations permeated popular culture, inspiring countless songs, films, and novels. The world was becoming increasingly interconnected, and air travel played a pivotal role in breaking down barriers, fostering understanding, and creating a sense of shared experience among people from all walks of life. The jet age, a time of glamour and innovation, continues to shape our world today. Technological advancements from jet engines to radar laid the foundation for modern aviation. The infrastructure developed connects people and places, facilitating trade and cultural exchange. The dream of supersonic travel lives on, inspiring new innovations. Engineers explore hypersonic aircraft and space planes, aiming to revolutionize air travel. The quest for faster, more efficient air travel continues, driven by innovation. The jet age's legacy is about exploration, connection, and pushing boundaries. It transformed our world, fostering global interconnectedness. The jet age pioneers inspire us to dream big and embrace innovation. As the jet age reshaped commercial aviation, the space race ignited a frenzy of innovation and national pride. The Soviet Union's launch of Sputnik in 1957 shocked the world, marking the start of the space race. Technologies from space exploration advanced aviation, leading to innovations in aircraft design and navigation. The expertise from the space program fostered a culture of innovation in both aerospace and aviation. While the space race was capturing headlines, the jet revolution was quietly transforming the aviation industry, making air travel faster, more efficient, and more accessible than ever before. The introduction of new generations of jet airliners, with their sleek designs, powerful engines, and pressurized cabins, allowed airlines to offer faster flights, greater range, and increased passenger capacity, all of which contributed to a steady decline in airfares, making air travel a viable option for a wider segment of the population. The Boeing 707, which entered commercial service in 1958, became the first commercially successful jet airliner, revolutionizing long-haul travel and ushering in the era of mass air transportation. The 707, with its distinctive swept wings, 4 powerful jet engines, and spacious cabin, could carry over 150 passengers at speeds approaching 600 miles per hour, significantly reducing travel times and opening up new, long-haul routes across continents and oceans. The success of the 707 spawned a wave of competition. as other aircraft manufacturers, including Douglas, Convair and Sud Aviation, rushed to develop their own jet airliners. The Douglas DC-8, which entered service in 1959, offered similar performance characteristics to the 707, while the Convair 880 and 990, with their emphasis on speed, catered to a niche market for high-speed transcontinental travel. The Sud Aviation Caravelle, a French-built jet airliner, introduced the innovative rear-engine layout that would become a hallmark of later aircraft designs, such as the Boeing 727 and the McDonnell Douglas DC-9. The jet revolution was not just about faster planes, it also ushered in a new era of efficiency and automation in the aviation industry. Airlines, faced with the challenges of managing increasingly complex operations, turned to computers and automation to improve efficiency, reduce costs, and enhance safety. The introduction of computerized reservation systems, for example, revolutionized the way airlines manage bookings, allowing passengers to make reservations and purchase tickets from anywhere in the world, while sophisticated air traffic control systems, aided by radar and computers, allowed for the safe and efficient management of increasingly congested airspace. The development of flight simulators, sophisticated training devices that replicated the experience of flying an aircraft, allowed pilots to hone their skills and practice emergency procedures in a safe and controlled environment, further enhancing safety and reducing the need for costly in-flight training. The use of simulators also allowed airlines to train pilots on new aircraft types more efficiently, reducing the time required to introduce new aircraft into service. The increasing sophistication of aircraft systems, while enhancing safety and efficiency, also placed new demands on pilots and flight crews. The era of the stick and rudder pilot, who relied primarily on instinct and experience, was giving way to a new breed of aviator, one who was as comfortable with computers and automation as they were with the intricacies of flight. This shift towards greater reliance on technology would continue in the decades to come as aircraft became increasingly complex and automated, blurring the lines between pilot and machine. Section 4. Safety in the skies, innovations and advancements. As air travel became more commonplace, safety became paramount. The aviation industry made significant strides in improving aircraft safety, from structural integrity to engine reliability. New safety features and procedures were developed. The introduction of jet engines presented new challenges, particularly in engine reliability and fire safety. Early jet age saw high-profile accidents, leading to improved engine design and fire suppression systems. Black box recorders provided invaluable data for accident investigations. Ground proximity warning systems and TCAS enhanced safety. Improved pilot training and maintenance standards reduced accident rates. Air travel became one of the safest modes of transportation. Section 5. Giants of the Sky. The rise of wide-body jets. The late 1960s and early 1970s saw the arrival of wide-body jets, revolutionizing air travel. These jets, with twin aisles and spacious cabins, made air travel more affordable and accessible. The Boeing 747, or jumbo jet, became an icon, capturing the world's imagination. Entering service in 1970 with Pan Am, the 747 was initially a stopgap measure. The 747's timing was perfect, meeting the demand for fuel-efficient, high-capacity aircraft. Its success led to the McDonnell Douglas DC-10 and Lockheed L-1011 TriStar. These smaller jets offered similar advantages, intensifying airline competition. Wide-body jets transformed aviation, making global travel more accessible and interconnected. Section 6. The digital cockpit computers take command. As aircraft became larger and more complex, the demands on pilots increased. The digital cockpit, with its electronic displays and automated systems, transformed pilots into systems managers, enhancing safety and efficiency. Fly-by-wire technology and GPS revolutionized navigation and air traffic management, offering precise control and efficiency. The digital revolution transformed the cockpit, paving the way for future automation. Section 7. Global connectivity, the impact of modern aviation. The advancements in aviation technology, from the jet engine and the wide-body jet to the digital cockpit and GPS navigation, have had a profound impact on the world, shrinking distances, connecting cultures, and fostering globalization. Air travel, once a luxury reserved for the elite, has become an integral part of modern life, facilitating business, tourism, and cultural exchange on a global scale. The world has, in many ways, become a smaller place thanks to the speed and convenience of air travel. The rise of low-cost carriers such as Southwest Airlines in the United States and Ryanair in Europe further democratized air travel, making it accessible to a wider segment of the population and fueling the growth of budget travel. These airlines, with their no-frills approach, point-to-point routes and emphasis on efficiency, challenged the traditional hub-and-spoke model of legacy carriers, offering travelers greater choice, lower fares, and the freedom to explore new destinations. The impact of modern aviation extends far beyond the realm of travel and tourism. Air cargo has become an indispensable link in the global supply chain, transporting everything from perishable goods and pharmaceuticals to electronics and heavy machinery across continents and oceans. The just-in-time delivery model, made possible by the speed and reliability of air cargo, has revolutionized manufacturing, retail, and other industries, allowing companies to reduce inventory costs and respond more quickly to changing market demands. The world has become increasingly interconnected, and aviation plays a vital role in facilitating the flow of goods, services, and ideas across borders and continents. Section 8. Towards a sustainable future, the next chapter in aviation. The aviation industry faces challenges like reducing environmental impact and improving fuel efficiency. It's a significant contributor to greenhouse gas emissions. Airlines are exploring sustainable aviation fuels, fuel-efficient designs, and new propulsion technologies. Urban air mobility could revolutionize transportation. It offers new mobility options, transforming how we live and commute. The future of aviation is shaped by innovation and sustainability. New materials improve fuel efficiency. New engines offer fuel savings. Digital technologies transform aviation. The journey of aviation continues, driven by ingenuity and exploration. Section 1. Aviation in the modern era. The 21st century ushered in an era of unprecedented technological advancement, globalization, and interconnectedness, and the aviation industry, ever evolving and adaptive, has played a pivotal role in shaping this new world order. Air travel, once a luxury reserved for the privileged few, has become increasingly accessible to the masses, connecting people, cultures, and economies across continents and oceans, with a speed and efficiency that would have astounded the pioneers of early aviation. Modern airliners, marvels of engineering and technological sophistication, ferry passengers and cargo across vast distances with remarkable efficiency and comfort. The Boeing 787 Dreamliner, with its composite materials, fuel-efficient engines, and advanced aerodynamics, has redefined long-haul travel, while the Airbus A350, with its spacious cabin, advanced avionics, and environmental friendliness, has set new standards for passenger comfort and operational efficiency. These aircraft, representing the pinnacle of modern aviation technology, are a testament to the ingenuity and collaborative spirit of the engineers, designers, and countless others who have dedicated their careers to pushing the boundaries of what's possible in the sky. The aviation industry, once dominated by a handful of established airlines, has become increasingly competitive. with the rise of low-cost carriers, regional airlines and niche operators, catering to a diverse range of passengers and cargo needs. This competition has driven down airfares, making air travel more accessible than ever before, while also spurring innovation in aircraft design, operational efficiency and customer service. The democratization of air travel has had a profound impact on the world, fostering global tourism, facilitating international trade and connecting families and communities across continents. As commercial aviation soars, private spaceflight captures imaginations. Once exclusive to governments, space exploration now thrives with private companies. SpaceX, led by Elon Musk, pioneers reusable rockets, reducing launch costs. Falcon 9 launches satellites and astronauts to the ISS. Dragon spacecraft proves commercial human spaceflight viability. Blue Origin, founded by Jeff Bezos, focuses on reusable launch vehicles and space tourism. New Shepard offers weightlessness and stunning Earth views, ushering in a new era of space tourism. Private spaceflight revolutionizes access to space. From satellites to Mars, private companies shape space exploration, opening a new chapter in flight history. As the aviation industry continues to grow, so too does its environmental footprint. Aircraft emissions, including carbon dioxide, nitrogen oxides and contrails, contribute to climate change, air pollution and noise pollution, posing challenges for the industry's long-term sustainability. Recognizing the need to address these environmental concerns, airlines, aircraft manufacturers and researchers around the world are working to make aviation more sustainable, seeking to reduce emissions, improve fuel efficiency, and explore alternative propulsion technologies. One promising avenue for reducing aviation's environmental impact is the development and use of sustainable aviation fuels, or SAFs, which are produced from renewable sources such as plant oils, algae, and even captured carbon dioxide. SAFs have the potential to significantly reduce life cycle greenhouse gas emissions compared to conventional jet fuel, and they can be used in existing aircraft engines, requiring minimal modifications to aircraft infrastructure. Airlines are increasingly incorporating SAFs into their fuel blends, and governments are implementing policies to incentivize the production and use of these cleaner alternatives. Another key area of focus is improving aircraft fuel efficiency through innovative design and technologies. Aircraft manufacturers are investing heavily in research and development to create more aerodynamic aircraft designs, reduce aircraft weight through the use of lightweight materials, and improve engine efficiency through advancements in engine technology. These innovations, combined with operational improvements such as optimized flight planning and air traffic management, are leading to significant reductions in fuel consumption and emissions. The quest for ever more efficient, sustainable, and transformative aviation technologies knows no bounds. Researchers and engineers are exploring a wide range of cutting-edge innovations, from electric and hybrid electric propulsion systems to advanced materials and autonomous flight technologies that hold the potential to revolutionize the industry and redefine the future of flight. Electric and hybrid electric aircraft powered by batteries or a combination of batteries and conventional engines offer the promise of zero-emission flight, reduced noise pollution, and lower operating costs. While challenges remain in terms of battery technology, range, and infrastructure, electric and hybrid electric aircraft are already taking to the skies in limited applications, primarily in the form of small experimental aircraft and urban air mobility vehicles. As battery technology continues to advance and the industry gains experience with these new propulsion systems, electric and hybrid electric aircraft are poised to play an increasingly important role in the future of aviation. Advancements in material science are also driving innovation in aviation. Lightweight composite materials, already widely used in modern aircraft, are being further refined to improve their strength, durability, and heat resistance, allowing for the construction of lighter, more fuel-efficient aircraft. Researchers are also exploring the use of nanomaterials, such as carbon nanotubes and graphene, which possess exceptional strength and conductivity, for potential applications in aircraft structures, engines, and electronic systems. Section 5. The future of flight challenges and opportunities. As the aviation industry charts its course into the future, it faces a number of challenges and opportunities, from addressing environmental concerns and managing increasing air traffic demand to embracing emerging technologies and adapting to evolving passenger expectations. One of the most pressing challenges facing the industry is the need to reduce its environmental impact. As global air travel continues to grow, so too do concerns about its contribution to climate change, air pollution, and noise pollution. Airlines, aircraft manufacturers, and policymakers are working together to develop and implement solutions such as sustainable aviation fuels, more fuel-efficient aircraft, and innovative air traffic management systems to mitigate the environmental impact of aviation and ensure its long-term sustainability. Another challenge is managing the increasing demand for air travel, particularly in rapidly developing regions of the world. Airports and airspace are becoming increasingly congested, leading to delays, inefficiencies, and increased environmental impact. The development and implementation of next-generation air traffic management systems, incorporating technologies such as digital communication, automation, and artificial intelligence, will be crucial for optimizing airspace utilization, improving efficiency, and accommodating future growth in air traffic demand. The aviation industry is also grappling with the challenges and opportunities presented by emerging technologies such as artificial intelligence, machine learning, and blockchain. These technologies have the potential to transform various aspects of the industry, from aircraft design and maintenance to passenger experience and cargo logistics. Airlines and aircraft manufacturers are exploring the use of AI and machine learning for predictive maintenance, optimizing flight operations, enhancing safety, and personalizing the passenger experience. Section 6. Aviation's enduring legacy. From the first tentative flights of the early 20th century to the sophisticated jetliners and spacecraft of the 21st century, aviation has undergone a remarkable transformation, shrinking the world, connecting cultures, and pushing the boundaries of human ingenuity. The journey of aviation is a testament to the enduring human desire to explore, innovate, and transcend limitations, and its legacy continues to shape our world in profound ways. Aviation has played a pivotal role in shaping the modern world, facilitating global trade, tourism, and cultural exchange on an unprecedented scale. It has brought distant cultures within reach, fostered understanding among people from all walks of life, and created a more interconnected and interdependent world. The speed and efficiency of air travel have revolutionized the way we do business, conduct diplomacy, and experience the world around us. The quest for innovation in aviation continues unabated, driven by the desire to make flying safer, more efficient, more sustainable, and more accessible. From the development of hypersonic aircraft and spaceplanes that promise to shrink travel times even further to the exploration of urban air mobility solutions that could revolutionize transportation in our cities, the future of aviation is filled with exciting possibilities. As we look to the skies, we can draw inspiration from the pioneers and innovators who came before us, those who dared to dream big, embrace challenges, and push the boundaries of what's possible. The journey of aviation, a testament to human ingenuity and the boundless potential of human endeavor, is far from over. Section 1. A legacy soaring high. As we conclude our exploration of aviation's remarkable journey from the mythical aspirations of Icarus to the modern marvels that grace our skies, we are struck by the sheer audacity of the human spirit, our relentless pursuit of progress, and our unyielding determination to conquer the seemingly impossible. From those first tentative forays into the heavens, fueled by a potent blend of curiosity and courage, to the sophisticated aircraft and spacecraft that define our modern world, the history of aviation is a testament to the power of human ingenuity, the transformative nature of technology, and the enduring allure of the unknown. Each generation of aviators, engineers, and dreamers has built upon the legacy of those who came before, pushing the boundaries of what was deemed possible, challenging the limits of speed, altitude, and endurance. From the Wright brothers' historic first flight at Kitty Hawk to the supersonic roar of the Concorde, from the massive cargo planes that crisscross the globe to the nimble helicopters that ferry passengers and provide life-saving services, aviation has fundamentally reshaped our world, shrinking distances, connecting cultures, and expanding our horizons in ways that were once unimaginable. The impact of aviation extends far beyond the realm of transportation and technology. It has shaped our culture, fueled our imaginations, and inspired countless works of art, literature, and film. The dream of flight, once the exclusive domain of mythical beings and fantastical creatures, has become a tangible reality, a testament to the enduring human spirit and our insatiable thirst for exploration and discovery. Section 2, the horizon of innovation. The horizon of innovation beckons with possibilities. Sustainable aviation, electric aircraft, and private spaceflight are transforming transportation and exploration. Challenges remain, but history shows aviation's resilience and innovation. The journey continues, pushing boundaries and shaping the future of flight.